Colossus from Peru. The heaviest animal that has ever lived on Earth has been discovered. An ancient whale whose remains were found in the Peruvian desert is the heaviest animal in Earth's history, according to a new study. Until now, this name was held by the blue whale, a newly described species from 39 million years ago may have weighed up to 340 tons. The blue whale, Balænoptera musculus, is no longer the heaviest animal that has ever lived on our planet. The newly described whale Pbqjk colossus, which swam in the oceans about 39 million years ago, may have been heavier than a blue whale, argue scientists from Peru and Germany who studied the remains of an ancient cetacean found in the Peruvian desert. The description and results of the research were published in the journal Nature. The potential rival of the blue whale was given the species name Pbqjk colossus, which can be translated as colossal whale from Peru. Its bones were discovered a decade ago by Mario Urbina of the Natural History Museum of the University of San Marcos in Lima. Over the years, they have been dug up by an international team of archaeologists working on the steep and rocky slope of the Peruvian Ica Desert. We know about this area that in the past it was underwater. It is also an area extremely rich in fossils. In the course of this work, bones were found, which are estimated to be 39 million years old. And the scientists emphasize that so far they have not encountered anything like it. In total, they managed to find 13 vertebrae, 4 ribs and a hip bone. They were then examined using 3D scanning. They also drilled into them to look inside. Then, using the collected data and comparing it to currently living marine mammals, an attempt was made to estimate the possible total weight and size of this colossus, as reported by Eli Amson, a paleontologist at the National Museum of Natural History in Stuttgart. First of all, each of the vertebrae of the ancient colossus weighs about 100 kilograms. The ribs themselves are about 1.4 meters long. Scientists estimated that its total weight could range from 85 to 340 tons. By comparison, blue whales weigh around 180 tons. It would therefore be possible that Pbqjk colossus was heavier than that of the blue whale. However, in terms of length, it was found that the Peruvian colossus could reach 20 meters, while in the case of fin whales it is even 30 meters. Where, then, would this difference to the disadvantage of Pbqjk colossus come from? Well, its bone density is much higher, so it can be heavier and smaller at the same time. Such bone density also suggests that it may have lived in shallower coastal waters. Of marine animals living today, for example, manatees also have quite dense bones. This is important because it makes it easier for them to stay closer to the seabed. So far, archaeologists have not yet been able to solve one mystery about the colossus from Peru. It is not known what his diet was like, which allowed him to reach such sizes. During the search so far, scientists have not yet found his skull, without which it is impossible to say. Scholars consider that it may have searched for food near the bottom or collected tons of krill and other small creatures. However, only finding his skull would confirm these assumptions. Human brains have shrunk about 3,000 years ago. Ants can help clear up the mystery. The brain is the most complex organ in the human body. New research brings us closer to understanding part of its evolution. Human brains shrunk around 3,000 years ago. Why have these changes occurred? It remains unclear. By studying ants as models, the researchers concluded that brain shrinkage may be due to humans developing complex communities. In the course of evolution, the volume of the human brain has almost quadrupled. This is a well-documented fact. What many people don't realize, however, is that sometime after the last ice age, that same brain began to shrink. As a result, our brains today are slightly smaller than those of people who lived about 10,000 years ago. When exactly did these changes take place and why did they happen? It remains unclear. A team of scientists has presented an intriguing new hypothesis in the journal Frontiers in Ecology and Evolution. It is based on the evolutionary history of a brain 1,000,000 times smaller than ours. That of an ant. A surprising fact about modern humans is that our brains are smaller compared to the brains of our Pleistocene ancestors. Why our brains have shrunk remains a great mystery to anthropologists, explains study co-author Dr. Jeremy De Silva of Dartmouth College. To unravel this mystery, a team of scientists from various fields decided to study the historical patterns of brain evolution. The researchers compared their findings with what can be seen in the ant world to provide a broad picture of the problem. An anthropologist, behavioral ecologist and evolutionary neuroscientist started sharing their thoughts on brain evolution and discovered that research in humans and ants could help determine what is possible in nature. Said study co-author Dr. James Traniello of Boston University. Most people are aware that humans have extremely large brains, much larger than our body size would indicate. In our deep evolutionary history, the size of the human brain has increased dramatically. Therefore, its reduction in size some 3,000 years ago was unexpected, he adds. Ants can provide different models that can help understand why brains can get bigger or smaller due to social living. Understanding this process is difficult using only fossils, Traniello explained. But what does an ant have to do with a human? Yes, and it has quite a lot. Although ants and humans are two completely different worlds, both humans and ants lead rich social lives, forming large, complex societies. In these societies, work is divided among workers of different specialties. The similarities also include agriculture. People started farming about 10,000 years ago. But, as scientists indicate, Ants were ahead of us in cultivating the land, and more precisely mushrooms, by millions of years. When the researchers analyzed models of brain size, structure and energy use by worker ants, they found that the organ had adapted to become more efficient in social groups. Perhaps, as the authors of the new study suggest, the human brain was shaped by the development of increasingly complex societies where knowledge can be shared and distributed among group members. Models have shown that group-level cognition and division of labor can influence adaptive variability in brain size. This means that in a group where knowledge is shared or individuals are specialists in certain tasks, brains can adapt to become more efficient, for example by reducing their size. With the advent of complex societies, human knowledge could be transferred to other members of the group, disseminating information among many people. Removing the need for an individual to absorb all the knowledge acquired by a group could theoretically relieve the brain. Ant and human societies are very different and have followed different paths of social evolution. Nevertheless, ants share important aspects of social life with humans, such as group decision-making and division of labor, as well as the production of their own food, agriculture. These similarities may point to factors that may influence changes in human brain size, explains Traniello. If group decision-making generated adaptive responses that exceeded the cognitive accuracy and speed of individual decisions, and had performance implications, then human brain size may have decreased as a result of metabolic cost savings, the study authors suggest. In this line of reasoning, the advent of the written word may also have contributed to the greater energy efficiency of the human brain. However, the authors admit that their hypothesis is based on a concept that probably cannot explain all the changes in the size of our brains throughout evolutionary history. The team of researchers analyzed more than 1,000 skulls of our ancestors and modern humans and found that the reduction in the size of the human brain began only recently, about 3,000 years ago. This is much earlier than previous estimates and several millennia after the first writing systems began to appear in the historical record. This means that the shrinking of our brains may essentially correspond to the expansion of collective intelligence in human societies. Other hypotheses suggested that after the last ice age, our brains began to shrink as a result of a change in diet. Competing theories held that this happened in response to a general reduction in the size of our bodies. However, new research does not support either of these explanations. Current research also does not fully solve the puzzle surrounding the volume of our brains, but it offers an intriguing new perspective, a model with which to compare our own evolutionary path. Our research suggests that the decline in our brain size was due to an increased reliance on collective intelligence. The idea that a group of people is smarter than the smartest person in the group, Traniello said,